Now let's understand the formula for combination. Friends, in my lectures I won't be using the term permutation. Whenever it is required to arrange the persons, I'll make the arrangement, and that we will see when we'll be doing the problems, right? No need to use permutation, you can straightforward go by combinations, right? Now the number of combinations that can be formed from n different objects taken r at a time is NCR, that is n factorial by r factorial n minus r factorial, right? Suppose you have 5 friends, and out of these 5 friends you wish to choose 2 friends, right? So you have to go this way, that is 5C2, right? 5C2. Now what 5C2 is? 5 factorial upon 2 factorial into 5 minus 2 factorial. So this is 5 factorial by 2 factorial into 3 factorial. Now this we have to solve, right? Now generally if we are making combination, what is happening over here? Suppose 5 friends are A, B, C, D, E. As we have done in the previous examples, we got the 10 combinations. It is A, B, A, C, A, D, A, E, B, C, B, D, B, E, then C, D, C, E, and then D, E. So in all 10 combinations are there, right? So if we solve this, it's 5 factorial, that is 5 into 4 into 3 into 2. This is 2 factorial, that is 2, and 3 factorial is 3 into 2, right? So we are getting 10 combinations, right? So that I have written over here. So if we have n objects and we have to select r objects out of them, so the formula will be NCR, right? The number of combinations will be NCR. And what is the expansion of NCR is n factorial over r factorial into n minus r factorial, right? See, I won't tell you the derivation over here because it will be really a time consuming process. You just memorize this formula, that is NCR is equal to n factorial by r factorial into n minus r factorial, right? So this is what the selection only, right? So this is the first thing. Now second thing, if we have to arrange n objects in various ways, so how many ways will be there, right? Let's take an example. Suppose I have 5 objects, that is P, Q, R, S and T, and I have to arrange them at 5 places, right? So for the first place I have 5 choices, for the second place 4, then 3, then 2, then 1, right? So this is what is 5 factorial that we have already done in our previous session, that the principle of counting we were using. So these are 5 factorial ways. So 5 objects can be arranged in 5 factorial ways at 5 places, right? That means n objects can be arranged at n places in n factorial ways. Okay, it's okay. So it's n factorial ways are there to arrange n objects at n places, right? Now let's relate the two, this one and this one. Now I'm here I'm writing down the entire incident. Just listen to me carefully. First of all, I have n objects. I have to select r objects, then arrangement of these objects to be done. Right, now go step by step. I have n objects. I'm selecting r objects, that means NCR. Out of n objects I am selecting r objects. Now till here I have done the selection. Now I have to arrange this selected objects, right? that is how many objects I have selected? R objects, and I have to arrange this R objects at R places. What will be the number of arrangements as we have just discussed? That is R factorial, right? So it's NCR. First of all, I made the selection, then I made the arrangement of selected objects in R factorial ways. So both the things are happening simultaneously. So it is NCR into R factorial, the complete solution to this problem. Okay, just listen to me once again. N objects, and we have to select R objects. So from N objects, we are selecting R objects, that is NCR. Then these R objects which I have selected, I have to arrange them at R places. So there are R factorial ways, right? So NCR into R factorial, this is the complete solution to this problem, and it is nothing but NPR, right? That is permutation. Now you got the difference between these two. Here only selection is there, then selection, then arrangement is permutation, right? So this is selection, this is selection, and then arrangement. So what is the difference between permutation and combination? Combination is strictly selection, and permutation is arrangement of selected objects, right? Arrangement, this is arrangement of selected objects. We selected R objects and we are arranging R objects, right? So arrangement of selected objects is permutation, and only selection is combination, right? So this is what the difference between these two, and this is the relationship between these two, right? NCR into R factorial is NPR, right? So as I had already told you that we don't have to use NPR, because whenever we are in requirement of arrangement, we can simply use R factorial, right? If we have to make a selection, then we have to arrange the selected objects, then we can go for NCR into R factorial. No need to use NPR, right? So you will never get confusion what to where to use NPR and where to use NCR, right? You just see whether if selection is there, do NCR. If you see after selection you have to make the arrangement also, so just arrange the selected objects in R factorial ways, right? So let's do some simple problems, then we will come to this permutation combination problem, right? Now I just expand it over here. NCR is n factorial by n minus r factorial into r factorial, and into this r factorial is np r. So r factorial is cancelled. So the formula for NPR is n factorial by n minus r factorial, right? I just rewrite the both the formulae. So NCR is equal to n factorial by r factorial into n minus r factorial, and NPR is equal to NCR into r factorial, right? So it is n factorial by r factorial into n minus r factorial into r factorial. So it's n factorial by n minus r factorial. Now whatever the data given to you, the values of n and r, just put in the formula and get the answer. If only combination, if only selections to be made, you use this formula. If after selection you have to arrange, then use this. Do not directly use this, you go by this step, right? The selection is done and then arrangement is done. So automatically you'll be getting this, but you won't be confused whether to use permutation or combination, right?